the Whelen Dashmaster II strobe with rapid rate feature. Was that a factory option? No, it was not. Did I want it? Yes, I did. The halogen version, the Dash Flasher, actually has 2 speeds. So why not the strobe version? The edge bar ended up with rapid rate feature. It was a single wire activation, much like the rapid halogen rate single wire activation on the Dash Flasher. There were UPS power supplies that had the rapid rate flash enhancement. All of these are double flash Strobe 2 products, and they all had the rapid rate enhancement. So why not the Dashmaster? Well, to get there, we have to understand a little bit about timing on both strobes and halogen flashers. And I'm going to butcher some terms and oversimplify this, more for me than anybody watching. But a 555 timing circuit is essentially what's used in both cases. And that's going to rely on 2 resistors and a capacitor, as well as the 555 chip itself. There's math to figure out what you're going to get as far as high time and low time in the output of this, and that's what actually runs the flash rate. But I'm not doing that math because DigiKey was nice enough to have a little tool where you could enter that stuff and get approximate values. And that's how I started this. But once I had approximate values and I knew it was safe to work with, I actually started with a halogen flasher. I figured it would be a little bit easier to deal with since I already knew how to change the flash rate on a Whelen Edge flasher, a halogen flasher. I figured I could go from there. So what I did was I took out the resistor, one of 2, that actually made the most change in the flash rate. And I replaced it with a couple different resistors that all worked within that math, and kind of took a look at what I got for flash rates. The higher the resistance, the slower the rate. My rig lets me just clip the resistors in and see what they do, and I knew it was in the safe range. So this would be the low value resistor, which gives you an extremely rapid rate. So I wanted to be in between there, which is 22K and 100K resistors. And so I found the sweet spot was somewhere in the 50 to 70 range. So I just started trying to see which one I liked and wanted to decide on one for slow and one for fast. I figured I could just alternate between the 2 of them, and that would give me my slow rate and my fast rate. And so I did that with a relay. I placed the higher resistance, slower rate on the normally closed side, and I picked the faster, lower value and put it on the normally open side. And what that allowed me to do was have a 12-volt trigger for that relay and just run the path that the resistor would follow through the relay and switch it between those 2 resistors. And that gave me a base low rate and a enabled relay high rate. Pretty basic sort of idea, just to see if that would even work. So here we are with it in its normal state. Now we're going to apply 12 volts to activate the relay. And now we are in the faster mode. So essentially all we're doing here is using a relay as a 12-volt switching device so that a 12-volt input will switch between these 2 resistor values that essentially choose our flash rate. Since a 555 timing circuit can be easily altered in this capacity by changing out the 1 resistor, I simply picked 2 values I liked and put one on the normally open and one on the normally closed side of the relay. Now it switches with a 12-volt input. Not extremely complicated or pretty. So the other option is to use a potentiometer as a variable resistor by connecting to the midpoint and the end point, you can use the potentiometer essentially as a dialed resistor. You'll see there is another resistor on the end there, and that was just so I could get my base flash rate to be what I wanted, and then adjust it from there. Theoretically, a potentiometer that was the actual range I wanted wouldn't really need that extra resistor. We can just think of that as setting the base rate, the flash rate that would be with the absolute least resistance through the potentiometer. That still goes through that extra resistor and gives us our base rate. So pretty simple. It's a dial flash rate. Instead of switching between two speeds here, we can dial in and just decide what speed we want. So how does that really help us with a 12-volt input switching? Well, it doesn't. So what we can do is we can combine the two concepts of the relay and the potentiometer if we like, and we can end up with two settings. One setting is going through the potentiometer, and you get whatever flash rate you set on the potentiometer. The other one bypasses the potentiometer, and you get the maximum flash rate that you would get without it, with just the base relay. So it's a bypass of the speed dial, essentially. The speed dial here does work. We can set our flash rate to whatever we want using the potentiometer, just like we did when it wasn't set up to be bypassed by the relay. We get a decent range of speeds here, and I actually didn't even bother dialing this in so that the max speed would be usable. This is an example. So when we activate the relay and we bypass the potentiometer, we get a stupid fast flash, which is the fastest it's capable of, essentially, with this setup. We're just completely bypassing that dial, taking it out of the equation, and going max speed, full send, pretend like the potentiometer's not there. If I had stuck a different value resistor as our base, we could make our max rate a little bit slower and make it usable. But since I was going to be applying this to other things, I didn't bother doing that. So here we have the UPS 52 with the rapid rate option from Whelen. And now what I needed to do was determine whether or not a similar technique would work on this power supply, which does have rapid rate. So I experimented with pegging, or taking the potentiometer and turning it, they actually call it a trim pot in this case, but turning it to its maximum flash rate and its minimum flash rate, and comparing that to what rapid rate does. So once we establish what rapid rate is on this power supply, I can then just tune that potentiometer, that trim pot, to its absolute max value and see if they're the same, which they appear to be. If you notice, with it all the way in its max speed, touching the rapid rate wire seems to do nothing, because it's already essentially in rapid rate. Because what Whelen has done here is they have bypassed that potentiometer with a 12-volt switching circuit. Now, they did not use a relay. A relay is kind of a crude way to do it. They used an optocoupler, which is essentially an optical electronic device that acts like a relay, essentially. That's an oversimplification, but they used a more advanced electronic way to do the same thing. So here I'm bypassing the trim pot, or the potentiometer, and if you see, when I bypass it by hooking the input and the output together, I do in fact get rapid rate mode. So at this point, I'm pretty sure that the way they did this was just by bypassing the setting altogether, like I had done with the potentiometer and the relay. So I didn't really want to add anything to the circuit board of my Dashmaster. I did play around with a Dashmaster power supply and tried a couple different things. Really what we needed to do was jumper the pins, and you can't just send 12 volts to the other pin. You have to jumper the two. So my options are going to be installing a physical switch on the back of the Dashmaster, which this Dashmaster power supply is disembodied and mounted to an Advantage center section, but that's beside the point. It's for demonstration, and there is a switch. The switch, when activated, will bypass the trim pot or potentiometer and put it in rapid rate mode. So I could drill a hole and put a switch on the back of the Dashmaster. I didn't want to do that. I wanted it to be like the Dash Flasher. I wanted a 12-volt input to trigger the rapid rate mode, not a physical switch. So while I liked this solution, and I think it would be fine for the Dash Lite if it were marketed commercially, I wanted to kind of simulate that switching that you found on the halogen version. So what did I do? Well, I didn't put a optocoupler on the circuit board. I just took a micro relay, the same type that they use to switch the light heads on and off, because you can do single light head mode in this. And I did exactly what I did previously with the potentiometer bypass and the halogen setup. I just jumpered the pins through that relay, and a 12-volt input will activate the relay and essentially take the trim pot or that potentiometer they're using for rate just completely out of the equation. So this is what I was able to do. I like the way it turned out from a standpoint of it looks like the way they may have done it factory, from the standpoint that it is a 12-volt input and not a physical switch. It would be more elegant to do it with some sort of transistor. It would be probably safer for the electronic components, but at the end of the day, this is what worked. Now, I did not retain the footage. Something happened to the footage of me actually building this, and I am not taking it apart because the relay fits in there in a very, very tenuous manner, and I'm going to break it if I take it apart, I think, and I'll have to resolder everything. And I actually potted some of the connections, and I don't want them to break, so I have to scrape all of the potting material off and resolder them. So unfortunately, I lost the footage of me actually building it. You'll have to take my word for it by looking and seeing that the 12-volt input does in fact cause rapid rate mode, and you can hear the relay click, so it's a relay. So that's how we made the rapid rate Strobe 2 Dashmaster, similar to the halogen Dash Flasher, with a rapid rate mode via 12-volt input. Thanks for watching. Have a great day.